Our next trend is called electronegativity, and all these trends I would like you to know the definitions of. So I'd like you to think of electronegativity is kind of like how the atoms are attracted to someone else's electrons. And so what it is the ability of an atom to attract electrons in a chemical bond. When we have two atoms that are bonding together, who wants the electrons more? And I love this picture here because it depicts like a tug of war. And so they're kind of like tug-of-warring or going after those electrons. And that's really electronegativity. Who wants the electrons more? Who's going to pull harder for those electrons? And so what happens is when we take the electronegativities, whoever pulls, we can get different scenarios happening. And I talked about a little bit in lecture. So you get different types. We talked about covalent. Covalent is sharing of electrons, but there's more than one way to share electrons. If you get an even sharing between the two atoms, and so they both kind of pull the same, so if you have the same element, they would pull the same when they're sharing their electrons, you would get a non-polar covalent. Basically, you're not going to get one that's positive and one that's negative. They're not going to get lopsided. You're not going to get poles is what it is. And they're both going to be happy. So no one's going to be upset in the non-polar world, non-polar covalent. If you have a polar covalent, I'm just going to introduce this word dipole because some of you will go on into Chem 2. You get something called a dipole, which means two poles. Means one side's going to be slightly more positive and slightly more negative than the other. And so you can see right here, if we get a big difference in electronegativities, if this one's not pulling very much, but it's still holding on to the electrons, and this one's pulling them more towards its side, this one's going to become slightly negative, this one's going to become slightly positive, and these will stick together. It is a covalent bond because they are still sharing those electrons. They're just not sharing equally. So this is an unequal sharing, is a polar covalent. And then when you get an ionic, basically one just steals the electrons from the other, and one totally becomes positive and one totally becomes negative. The others was just more of a slide. So it's kind of like a sliding scale, so of stealing the electrons, almost stealing the electrons, and sharing very, very equally with one another. So I wanted to show you this depiction here. So on ionic, those electrons completely transfer to one. And remember, when they gain electrons, they get larger here. So we've got a negative and a positive. They do stick together. That's an ionic bond. In here, they're sharing the electrons, but this one's going to be slightly more negative. This one's going to slightly be positive. So this is the way we sometimes will depict that, and we will look at that in Chem 2. So this means a slight negative and a slight positive, and that's because those electrons are being moved more on this. And so we say that's a polar covalent compound. They're still stuck together. The electrons are still being shared. This one, we don't get either one of them charged, and this would be an equal sharing. And the way we do that is we take the electronegativity values and we subtract them, and wherever they range, that's going to tell us what type of bond that we have. And so when we talk metals and nonmetals, metals are very low in electronegativity because they don't really have that attraction. That's why they form cations so well. But nonmetals are always trying to gain electrons, so they're very high electronegativities. And so the trend is pretty much like ionization energy. It's more to the right and up. So the radius was down and to the left, and the other trends are to the right and up. The difference with this one is going to exclude our noble gases. So that's going to make fluorine the most electronegative element on our periodic table. We're also going to see that oxygen and nitrogen are very high in values, and for those of you that take Chem 2, there's going to be a reason we need to know those particular three elements, that nitrogen, oxygen, and fluorine are really high electronegativity. But for you guys, fluorine is the most as far as electronegativity. So why not helium? Well, helium or none of the noble gases have an attraction for electrons, which is what electronegativity is. So this one, yes, is up and to the right, but it is going to exclude the noble gases. They don't have an electronegativity because they don't have that attraction for electrons. And so the trend is up and to the right, but I'm going to stop and point right there at that fluorine and block out that noble gas because the noble gases do not count in this trend. And so that leads us to Linus Pauling. Pauling came up with a scale, kind of like a 4.0 scale. He's measured each atom based on a 4.0 on how electronegative they are. And we can take the values and subtract them, and depending on where it falls, it's going to tell us if it's ionic, covalent, polar, or nonpolar on the covalent scale. So if it's 0.4 or less, it's going to be nonpolar. If it is greater than 1.7, it's going to be ionic, and in between, so greater than the 0.4, so that really should say greater than the 0.4 and less than the 1.7, then we're going to see it polar covalent. Different books will change, so if you go on to organic and you see that number change slightly, it just depends on the book, but for us, my numbers are going to be big enough that you'll be able to see. So this is the way this scale looks, and let me take a picture of that so we can use it. And so you'll see that fluorine is 4.0. It is the most electronegative. We're not seeing those noble gases on there, and you can see that francium over here 0.7. So it's kind of like a GPA. That one doesn't care very much, and this one cares a lot on that. So we're going to use those values. So let's look at our examples that we've got. So I found this depiction. I really liked it. Can you see that both atoms are sharing equally? This would be a nonpolar covalent. This is an unequal sharing, so those electrons are more towards the B. So B is going to be slightly more negative, and A is going to be slightly. This is what we call a dipole. Dipole means one side slightly positive, one side slightly negative, which leads us to a polar covalent bond. And then one atom completely takes electrons away. That's going to be an ionic. So let's look at these three. We've got a bond between CH, a bond between CO, and a bond between sodium and chlorine, NaCl. So let's look at those and let's see how we're going to do those. So let's take the CH first. And so we would look up the electronegativities and we're going to subtract them. And we're technically going to take the absolute value, or we can just say we're going to take the big number minus the small number. So we're going to go back to our chart and find C and H. And so carbon is 2.5 and H right there is 2.1. So we're going to subtract 2.5 and 2.1. So 2.5 minus 2.1, and you get a 0.4. So 0.4 is going to be a non-polar covalent bond between those. And you guys that go on to organic, you're going to see lots of CH bonds, and you just need to know that's a nonpolar covalent. All right, what about carbon and oxygen? So we know that carbon is that 2.5, oxygen is 3.5, so it's more electronegative. So we take big number minus small number, or take absolute value, you get 1. Well, 1 falls into this category, and so this is going to be a polar. All right, and then we got NaCl, so that's sodium chloride, and so chlorine is here at 3.0, and you don't need to memorize this. I definitely would give you these numbers. Okay, you just need to know what they fall in between. So we got 3.0 and 0.9, and so we're going to subtract the 3.0 minus the 0.9, and you get 2.1, which is greater than 1.7, and we probably should know this is an ionic bond where most metals and nonmetals fall into. All right, these are the numbers that you need to memorize for your test, so you need to know that. Technically, if you know this one and this one, you know that one's in between, you should be good. All right, that's electronegativity, so let's look at the last little slide on this PowerPoint where it just has all our trends Radius is down and to the left, and both electronegativity and ionization are up and to the right, with electronegativity excluding the noble gases. Noble gases not for the electronegativity. All right, that concludes the trends.